everybody. Today we're going to be looking at, oops, I've got the wrong number on there. That's supposed to be section 2 of chapter 4. Everybody change that 3 to a 2. That's supposed to be section 2, not 3. I guess I'll have to go back in and change that, won't I? Let me fix it on my key. All right, so we're going to look at how we describe energy today. What are the different types and that kind of stuff. But first, we need to look at the main idea. And the main idea is that if you have energy, that energy will cause changes. Or, if you will, do work. If you've got energy, you can use it to do work, all right, which we've already talked about in the first section. Remember, it's a force exerted through a displacement. Well, to exert your force, you've got to have energy to do that. So energy will cause changes. Oops, I left the S off the changes there. There we go. And it will do work. Now, so energy basically, and some of you may remember this from another class, it's the ability to do work, to cause change. And generally, we use a capital E for energy, and then for various types of energy, we might put another letter in front of it. Now, without energy, if you don't have energy, nothing will change, okay? It takes energy to make changes, to do work. Now, it's interesting to note right here that work and energy are measured in the same unit. If you remember, we measured work in the unit called the joule, named for James Prescott Joule, a famous scientist. And we use a capital J at the end of the measurement. Energy is measured with the same unit. Now, why in the world are work and energy measured in the same unit? Well, that's basically because if you do work, you're converting energy from one form to another. And the amount of work you do is a measure. The amount of work is a measure of the energy converted. So, for example, a car uses chemical energy in the fuel, and it does work to convert that chemical energy into kinetic energy for the car. So the amount of work done measures how much chemical energy was converted into kinetic energy. So if the car does 1,000 joules of work, it converts 1,000 joules of chemical energy into 1,000 joules of kinetic energy, okay? So work is a measure of energy converted, and since it's a measure of energy, it's measured in the joule also, just like energy. Now, there are 7 basic forms of energy we're going to look at, and there are many others, but the basic forms are the main ones, and then any of the others are usually just various forms of those types of energy. So, for example, the first one is kinetic energy, but there's a number of different types of kinetic energy. For example, kinetic energy, which is energy of motion, you could talk about the kinetic energy of a car moving down the road. But not only do you have kinetic energy if you're moving along at some speed, but other types of energy that you wouldn't think of are also kinetic. For example, if you look at the energy that turns a windmill, it's the wind that turns the blades of a windmill, but what is wind? It's nothing more than molecules of air that are moving at some speed. So the wind is a type of kinetic energy, isn't it? Sound waves. Sound waves are also a type of kinetic energy. When you make a sound, it vibrates the molecules. Those hit the next molecules and make them vibrate, and then those hit the next molecules and make them vibrate. So it's all about moving the molecules and passing the energy from one molecule to the next through a collision. So that's kinetic energy also. Then another basic type of energy is potential energy, and there's various forms of potential energy as well. In fact, we'll be looking at some of them in a few minutes. Then there is chemical energy, which I mentioned earlier. Chemical energy, such as the energy in a chemical reaction. For example, a battery uses a chemical reaction inside to create an electric potential difference so you can use it for electricity. So a battery uses chemical reaction energy. Light energy, like from the sun, or a light bulb, or a flame. Light energy or sometimes you'll hear it called, in upper level physics, you'll hear it called electromagnetic energy, because that's what it is basically, electromagnetic energy. But for our purposes, light energy is good enough. Light, or if you want, solar energy. Same thing. Another type would be thermal energy. Now, as you know, thermal is simply a fancy word for heat. So we're talking about heat energy, like again from a flame or the stove on the eye on a stove or an oven. Heat energy is a basic form of energy. Then, of course, the one we can't live without, electric energy, that runs all of our appliances and, of course, our cell phones. We couldn't live without them. Well, I could, but I don't know about you guys. So anyway, electric energy, the energy carried by electrons moving through a conductor like a wire. Then there is, on the very small scale, there is energy contained in the atom and then in the nucleus of the atom. So we have atomic or nuclear energy as well. And that can be harnessed using a fission process, okay? So 7 basic forms of energy. All other forms of energy fall under one of those categories. In fact, I have some pictures right here of examples, like electrical energy lights the light bulb, and you've got heat from the fire, and potential energy, they're high up above on top of the roller coaster ride, so they have potential to do work as they come down. Chemical energy, using reactions right there, atomic or nuclear. Kinetic is motion of an object. The only one that's not really on here is light, but you could look at the light bulb as having light energy too. All right, now, before we talk about energy of a system, we need to understand what a system is. A system is simply the group of objects of which you're focusing on, okay? And that should say group, not groups. The group of objects of focus. For example, maybe you're playing pool at a local rec hall. So when you put the billiard balls on the table and you break the balls and they go in every which direction, that would be a system of objects. All the balls that you're focusing on, all of those billiard balls. Some other examples I have here. You could have a system containing the baseball and a bat hitting it. Okay, that would be a system of 2 objects. You might have a locomotive pulling a whole bunch of boxcars on the train. You could consider the locomotive and the boxcars to be a system of objects. You might have 2 cars colliding. The 2 cars could be the system. An airplane flying could be a system. A flock of birds or a school of fish could be a system. So a system is just the group of objects on which you're focusing for a physical phenomenon. Now, whenever you have a system, and we're going to underline this, when one system does work on another system, energy is transferred from the first to the second. Okay? For example, a person eats an apple, which gives him chemical energy in his muscles, and that converts to kinetic energy for the bicycle. A battery takes chemical energy, and when placed in the light bulb, the light or placed in a flashlight, the chemical energy gets converted by the light bulb into light energy. You can plug in a lamp. Electrical energy from the outlet gets converted by the lamp into light. Chemical energy in the fuel of a car gets converted into kinetic energy for the car's motion. Light energy from the sun gets converted by a plant through photosynthesis into chemical energy it uses for food. And again, plug in your toaster. Electrical energy gets converted to heat energy to toast your toast, toast your bread. Okay? So, systems can transfer energy from one to another. You can also transfer energy between parts of one system. Usually, whenever there's a transfer of energy, as you can see here, it changes form. It doesn't stay in the same form. It changes from one to another. And that takes work. And whenever you do work to change energy, every joule of work you do, you transform the same amount of joules of energy. It's a 1-to-1 ratio. 1 joule of work done, 1 joule of energy transformed. Now, let's look at some of the common forms of energy specifically, and we're going to look at 2 particular types for this chapter because we're dealing with motion and mechanics. So we're going to look first at kinetic energy, energy of motion, because we've been talking about moving objects. Remember, in Chapter 2, we learned how to describe the motion of objects. In Chapter 3, we learned about the forces that cause the motion. Now we're looking at the energy of the motion. And for kinetic energy, we use a capital K, capital E. That makes sense, kinetic energy. And it's due to motion. So you got to be moving to have kinetic energy. And to find the kinetic energy, you say 1/2 times the mass of the object times the speed of the object squared. And believe it or not, one of the most common boo-boos in using this formula is people always forget to square the speed. So be careful about that. We've got to remember to square the speed. So let's look at an example real quick. Let's suppose we have a jogger. Now, as you know, joggers jog. That's moving. This particular jogger has a mass of 60 kilograms. So I'll put an M on that. And he's moving forward at a speed of 3 meters per second. So there's our speed. And we want to know what is the jogger's kinetic energy from this forward motion. So we've got a mass, we've got how fast he's going, and we want how much kinetic energy is associated with that speed for his mass. So we're going to say 1/2 mv squared, and that will be 1/2 times 60 kilograms times the 3 meters per second, but don't forget the speed is supposed to be squared, okay? Now, we need to stick this in our calculator. Sometimes people have trouble understanding what to do on the calculator if you have numbers like this and then you have a little fraction. Well, guys, 1/2 of anything in decimal form, 1/2 is the same thing as 0.5. So you don't have to stick in 1 divided by 2. Just stick in 0.5, the decimal form, okay? 0.5 times 60 times 3 squared, okay? Now, if you'll take a moment and put that in your calculator, pause the video, put it in your calculator, see what you come up with, and then you can compare to the answer that I get, okay? All right, if you've put that in your calculator, 0.5 times 60 times 3 square, and then hit enter, you should have gotten 270 joules of kinetic energy for this jogger. Okay? You just stick in 0.5 times 60 times 3 squared, enter, and you should get 270. Easy peasy, lemon squeezy. Okay? So kinetic energy is an energy of motion. If you know the speed of the object, you can easily calculate its kinetic energy at that speed. Now, obviously, if the speed gets bigger, 3 squared gets bigger, so the kinetic energy gets bigger. If the speed gets smaller, the speed squared gets smaller, and the kinetic energy gets smaller. So the faster you go, the more kinetic energy you have. All right, now let's go to the next page and look at another basic form of energy, and that is potential energy. Now, like I said on our list, potential energy, there are various forms of potential energy. Boy, I don't guess I needed quite such big blanks, did I? We use a capital P in front of the capital E for potential energy. Now, potential energy is just that. You have the potential to do work even though you're not using that energy. So it's stored energy. Potential energy is stored energy. And we're going to look at some 3 different types of stored energy. And the first one is elastic potential energy. Now, this is the energy that's stored when you compress or stretch a spring or maybe a piece of elastic, like, for example, oh, hold on, I had one right here, and it's vanished. Oh, I was going to say a rubber band. Oh, wait, is that one? No, that's not one. Okay, let me get one. Hang on just a